which again is not sort of the end of the world. You have to add a case to everything, but it can just never be realized. But it's very unpleasing. I don't like it. So the open way is kind of annoying, and this closed way is both honestly quite confusing to keep track of, but also B, you maybe can't deconstruct values. You can construct them, but it's maybe not possible to destruct them, which, if true, is a fatal flaw. So unfortunately, after reading through these papers, and his earlier one, it seems like making these schemas is actually a primitive operation. You unfortunately just need to keep track of your schemas, which is very sad because it feels too heavyweight. It feels like there should be a much smaller language in here that that doesn't require this sort of thing. But here we are. So what we're going to try to do then is how we're going to define vect. It'll still be of the same type. It'll be UO to N to U0. But the way that we're going to... Jesus. The way that we're going to define it is we're going to say it's a schema, which is very similar to a primitive. Except it's going to take a couple of things. Possibly only one thing. I'm not entirely sure how I want to do this yet. It's going to take the parameterized types, which in our case will be the type A, and the index types, which is the type N. I'm not sure if I want to track these separately. I don't fully understand why you would do this. Like, I get the description of what it is. Parameterized types, it has to be the same type for all constructors, but index types you bind separately. Well, okay, this is not actually a separate bind. But index types you bind separately for all branches. Like, I understand the description of what it is, but I don't understand why you would have that distinction. It's not clear to me why you wouldn't make just everything indexed. But anyway, and then from here we're going to describe our nil is vect, or yeah, our nil is a vect A0. So this is basically the same as Idris and Agda, unfortunately. I was hoping that I could get away with not, but I can't. Or at least I haven't figured out how. Successor of N. Alright, like that. And so this has a couple of advantages. One is that vect is not... types are, in some sense, special. They're not really special, but they are somewhat special. And so using this schema keyword very clearly marks the type vect as a type and not just as a term. The second one is that all the constructors are listed here in closed form, and so it's quite easy to pattern match on them because we know them. And the third one, which I'm not sure how I'm going to exactly do it, because I'm not sure if I am going to. But a third potential one is that nil and cons become... You don't have to go like nil of n. Right. And I don't know, maybe you will have to do that. I haven't exactly decided. But here, nil is not a function from A to vect A0. Nil is automatically of type vect. Well, the A is already bound. I guess technically in here you need a bound n. Yeah, it's not super clear to me why you would do this. I don't really understand the distinction or the kind of theoretical basis for why this happens. And no one ever gives good examples of these things either. They're just like, oh, this is a thing you can do. Now we're done. Our job is done here. It's like, all right, sure. Fair enough. So then if we try to type map, right? So A of U0, N of type N, B of type U0, A to B, vect AN, vect BN. Alright, so now if we try to write our map function, then we can deconstruct the vector here quite easily because we know precisely what it deconstructs on. So if we try to match, let's just do this notation. What's a nice way of doing this? I guess we'll do it like this. So if we try to match on VS, then we have nil. We're just going to return nil, though implicitly this is now the B, vect B0. So this is vect A0 and this is vect B0. Again, I'm not sure if I'm going to force an include of the B here. I don't know yet. And then this one is cons A, AS, oh, also the N, I forgot about that. We'll do M, A, AS. So in this case, it's just nil, and in this case, it's cons. I guess M, FA. Shit, I'm gonna run out of room. Map. A. Should be the successor of M. Fuck. Oh no, it is. It is. This is the. This can just be N, actually. We'll just reuse N. It's fine. Successor M and whatever. Will it be able to figure that out? Yeah, it'll be able to figure that out. That successor N is M. Yeah, because those two are linked that way. Yep. And then what? We have A, we have M, we have B, F, and AS. Like that. Right, so this is just how it's usually done independently typed languages like Agda and Idris. Sort of. I mean, they have different keyword, but this is essentially how it's done. It saddens me to be introducing this as a fundamental primitive. It feels like it should be able to be broken down, but reading through these papers, I get the impression that this kind of recursive or inductive definition is a primitive, but they just don't even think of it as a primitive. It's just, we're just defining a type. But yeah, okay. So that was a lot of writing. That was like an hour without coding or something, maybe even more. So let's try to, again, I'm not sure what I'm gonna do here. I don't really understand why you would want to break them up like that. Other than just the fact that this match here, you match on this. I guess that's nice. I mean, you can match on N anyway. I guess the benefit is, yeah, when you're destructing, They can have different values. Anyway, we're just gonna follow the well-trodden path. Very sad.